Hey guys, so a bunch of you asked for me to do a video on how to solve these math problems. So that's what I'm going to do on this video here. Um, so we're going to start off with the first problem that we did in class. And notice I've got a calculator floating around here. I'm going to show you how to do the math on it as well. So you're getting the right numbers on your calculator. All right, so the first question is, how far apart are a 10,000 kilogram object and a 1,000 kilogram object that have a force of 250 newtons acting between them? So the 10,000 kilogram, because it's the bigger mass, is big M. 1,000 kilograms, because it's the smaller mass, it's little m. 250 newtons is F, that's your force. For these problems, we're dealing with planets and large objects that have to have the law of universal gravitation, which is 6.67 times 10 to the negative 11th, and we're looking for the radius. So we're going to look for this, use this formula here. Gravitational force is equal to gravitational constant times the product of the two masses divided by r squared. So I have 250 newtons is equal to 6.67 times 10 to the negative 11th times 10,000 times 1,000 divided by r squared. So the first thing I'm going to do and my calculator's not working. Well, forget about the calculator then, because it's not working. First thing I'm going to do is multiply 1,000 by 10,000 times 6.67 times 10 to the negative 11th. And problem fixed. And I'm going to do times 10 to the negative 11th. And I get 6.67 times 10 to the negative 4th divided by r squared is still equal to 250. So I'm going to multiply r squared by both sides to get 250 times r squared is equal to 6.67 times 10 to the negative 4th. And then to get r by itself, I'm going to divide both sides by 250. Now, if you have a TI calculator, all you have to do is hit divide, and it's going to bring up my previous answer divided by 250. And I have 2.668 times 10 to the negative 6th. Now, now it's r squared is equal to this. So I want to take the square root of this number. So I go second function, square root, second function, answer, and I get 0.0016 meters. So there is the first question. Okay, you can go back and take a look if you want to figure out how to do it, if you need some help. All right, the next question is this one. I'm going to clear off my calculator here. What is the period of a planet 4 times 10 to the 11th meters away from a 5 times 10 to the 35th kilogram star it orbits? So we're looking for period, we're looking for t. We have a meter, that's my radius, 4 times 10 to the 11th. We have a mass, 5 times 10 to the 35th kilograms, and all these problems involve g, so we have g 6.67 times 10 to the negative 11th. So we're going to use, because we're looking for period, the time it takes to complete an orbit. The only formula we have like that is t equals 2 pi times the square root of r cubed over gm. That's an expanded version of Kepler's third law of motion. So I'm going to take and solve for t now. So I have 2 pi times the square root of r squared. So r is 4 times 10 to the 11th, so we have to cube that, or r cubed, sorry. So I'm going to take 4 times 10 to the negative 11th. Now on the TI calculators, I can hit math 3 to cube that, and I get 6.4 times 10 to the negative 32nd. I'm going to actually change this because I made a mistake on my okay. Oh, give me just a moment here. So if you notice, it should be to the positive. I made a mistake on my calculator. I did negative first, instead of positive 11, so it should be 6.4 times 10 to the 34th. So 6.4 times 10 to the 34th. Now I'm going to multiply 6.67 times 10 to the negative 11th times 5 times 10 to the 35th. And I get 3.335 times 10 to the 25th there. So now I can do 6.4 times 10 to the 34th divided by, and it's my 3.335 times 10 to the 25th. I can do by my previous answer. Okay, so that gets me this really long number here. Now I'm going to take the square root of that. And I get 48,000 or 43,806. I'm going to take that number times 2 pi. And I get 275,246 seconds. Okay, so that's the next one. Now remember, your calculators might be slightly different. Okay, next question. Number 3. All right, so what is the orbital velocity of an object orbiting at a 3 times 10 to the 20th kilogram star, 2.8, 2 times 10 to the 8th meters from the star's center? So we're looking for velocity, so we're looking for v. We know m, we know r, and we know g. Okay, so I'm going to clear my calculator again. So I know the equation from v equals the square root of gm over r. G is 6.67 times 10 to the negative 11th. M is 3 times 10 to the 20th. R is 2 times 10 to the 8th. So I'm going to do 6.67 times 10 to the negative 11 times 3 times 10 to the 20th. And that gets me 2 times 10 to the 10th. Now I'm going to divide that by 2 times 10 to the 8th, which gets me 100. So I'm going to take the square root of 100. And I get 10 meters. Okay, so that's number 3. Moving on to number 4. Clear off my calculator. Okay, so a satellite is traveling at 25 meters per second at a distance of 2 times 10 to the 6 meters above a planet. What is the mass of the planet? So we have v this time, that's 25 meters per second. We have r, which is 2 times 10 to the 6 meters. We have g because it's always the planet piece. Now we're looking for big M. So we're going to use the same v equation. Okay, so I started off by taking my v is 25 is equal to the square root of g times m divided by r. We don't know m. So the first thing we're going to do, like I have written here, we're right at the formula. Then I'm going to square both sides. So 25 squared is 625. So 625 is equal to 6.67 times 10 to the negative 11th times m divided by 2 times 10 to the 6th. Now, what I'm going to do is I'm going to divide 6.67 times 10 to the negative 11th divided by 2 times 10 to the 6th. So 6.67 times 10 to the negative 11th divided by 2 times 10 to the 6th. And over there I should get, like it says here, 3.335 times 10 to the negative 17th. So now I'm going to divide 625 divided by 3.335. And I get 1.87 times 10 to the 19th kilograms. Okay. On pretty much every calculator, when I did 6.625 divided by, there's always a thing that says ANS. That's your previous answer on the calculator. So it just takes the previous line. All right, number 5. All right, what's the gravitational force between a 100 kilogram object and a 5,000 kilogram object separated by half a meter. So we're going to use the first equation. F equals G times M divided by R squared. Here comes the calculator. So 6.67 times 10 to the negative 11th is G. 5,000 kilograms is big M. 100 kilograms is little m. R is 0.5. So 5,000 times 100 is 500,000 right there. I'm going to take that times 6.67 times 10 to the negative 11th. So I get 3.335 times 10 to the negative 25th, or 10 to the negative 5th. Oh, 0.5 squared is 0.25, so I'm going to divide that by 0.5 squared. And I get 1.334 times 10 to the negative 4th newtons. Okay. Final question on this. If a 75 kilogram object is 6.4 times 10 to the 6 meters, this should be meters, from the center of a 5.9 times 10 to the 24th kilogram object, what is the force of attraction between the objects? So we're going to use the same force equation, and we're going to solve for the force. So my force we don't know. I know G because we're dealing with the gravitational force with planets. The big M is 5.9 times 10 to the 24th. The little m is 75. R is 6.4 times 10 to the 6th. And we're squaring that whole thing, the whole number on the bottom. So I'm going to first multiply 5.9 times 10 to the 24th times 75 to get me this number, 4.425 times 10 to the 26th. Next, I'm going to square 6.4 times 10 to the 6th. To the 6th. And then I'm going to square that. And I get 4.096 times 10 to the 13th. Okay. Next, I'm going to take 6.67 times 10 to the negative 11th times 4.425 times 10 to the 26th. And I get 2.951 times 10 to the 16th. Divided by that, divided by my 4.096 times 10 to the 13th. 4.096 times 10 to the 13th. And I should end up with about 720 newtons. Now, you can go back and look at how I did this, see which buttons I pushed. Just follow my mouse. Okay? And if you have other questions, ask me in class. I hope this helps, and we'll see you in class.